Hello everybody. Today we will take a look at a KBAT question from AdMaths. This is one KBAT question on quadratic functions. So for KBAT questions, right, the main type of sources of questions they have are usually structures like this, because quadratic functions, they have graphs like this. So usually we'll talk about structures and things like we have a U-shaped structure. For example, here we have a bridge, and this bridge has an arc-shaped structure, which is like a quadratic function. This is why they model it this way. Okay, now we read the question. The diagram shows the side view of a bridge. The curved part of the bottom is supported by 5 steel poles, these 5. And the height of each pole is represented by this function. Okay, where x is a distance from the first pole. This information is very important, because in order for us to put our equation into real life, we must know what x is. Okay, so this piece of information is very important. And then from here, we can see, because of the shape of the graph, we expect a to be negative. This is what we expect. Let's see what we get from calculation. So given that the length of the bridge is 200 meters, and the height of the first pole is 5 meters, which is what they measured, and they gave already the length of the bridge is 200 meters. We want to find the length of the highest pole, which is this one. So because we are looking at this quadratic function, right? We are looking at this quadratic function. Eventually, we want to think of a way to find the maximum point. Okay, because we want the highest pole, we want the maximum point in the end. And here we actually, before we start this question, we have to make one assumption. We must assume that the poles have negligible width. Okay, this means that we don't consider the width of the poles at all, because otherwise, if we don't have the width of the pole, we really cannot start doing this question. Okay, so we are going to assume that the poles have no width. So here, this is my x equal to 0. I know this is x is equal to 0, and then now we can start doing this question. Okay, now we know the width of the bridge is 200 meters, and at the end point here, this is also 5. Correct or not? Because these two poles, they must have the same length, otherwise the bridge is kind of weird. Okay, it won't stay still. So from here, we know at the end of the bridge also height is 5 meters. So we can plug this into our equation. We know when x is equal to 200, our h is equal to 5. Okay, we plug this information in. This allows us to find a. Plus half 200 plus 5. This is equal to 5. From here, we can find out a already. So these two cancels. And then here we can divide 200 because everything is gone, right? So we have 200a plus half is equal to 0. 200a is negative 1 over 2, and therefore we can find the value of a. A is 1 over 400. Okay, now that we have a, we can actually try to figure out the width. Okay, we can actually try to find out the height of the pole. So now we know our function already. Hx is negative 1 over 400a squared plus half x, 1 over 400 x squared plus half x plus 5. So from here, to find out the height of the pole, we have two approaches. You can either use by completing the square. You can complete the square to find out the maximum point. This is one approach. Or the second approach is by symmetry. We know that the maximum point must be at the center. Okay, quadratic functions, they have one special symmetry property. Because we know these two, they have the same height. It means that the height must be at the very center, the highest point. This is the highest point. So from here, we can see the highest point is at x equal to 100, the actual center. So to find the highest point, all we do is we can substitute in 100. So I put 100 into my hx, this function over here. And from here, I can get my answer already. okay, I should get 30 meters. Okay, for maths, we can just put our answer at the final part. So hx is 30 meters. This is the height of the ball.